Hi, in this video I will present the Coastal Risk Assessment Framework. For more information, please consult the Deliverable 2.3 Coastal Risk Assessment Framework guidance document available on the RISC-KIt website. The Coastal Risk Assessment Framework, CRAF, is one element of the open source and freeware RISC-KIt toolkit and help for assessing hotspot area at a regional scale, using hazard models, a vulnerability library, impacts model, and a multi-criteria analysis. As you can see on the picture here, the CRAF select hotspot, which then can be considered for more detailed assessment using the early warning and decision support system, the web-based management guide, and the coastal risk database. These different elements are all designed for Europe's coastal manager, decision makers, and stakeholders in order to evaluate the effect of climate-related socio-economic and cultural changes on coastal risk and choose the best prevention, mitigation, and preparedness measures. With the CRAF, you can identify and rank hotspots at the regional scale. Why would you like to do that? Well, first, to increase your understanding of the potential risk along your coast, to define and identify where further detailed modeling might be required, but also to increase your understanding of the available data to do your assessment and to improve your decision. The CRAF has been developed as a framework that could be used in a diversity of coastal settings, which means different geomorphic settings, different type of hazards, different level of exposures, different socio-economic setting, and various value. Before explaining what is in the CRAF, let's look at some definitions that have been used in the development of the framework. Hotspots. We consider hotspots as critical coastal areas of about 10 km in a longshore length. The region is a large sector along the coast of about 100 km. They could be defined by administrative units or management units. It's always case study specific. The risk is the probability of a hazard and its consequences, and the source pathway receptor consequences model is used for the assessment. By source, we are considering the storm, which could be defined by waves, water level, or rainfall. The hazard can be coastal flooding, erosion, overwash, but also flash flooding. The receptors are any entities potentially at harm directly, that means that are exposed to the considered hazard, or indirectly. And the consequences are the loss of assets, but also the disruption of services and the recovery process. Finally, the Coastal Risk Assessment Framework uses indicators. Indicators are a qualitative or quantitative estimation of the state. The CRAF provides two levels of analysis, CRAF Phase 1 and CRAF Phase 2. From an overall perspective, CRAF Phase 1 is a screening process based on a coastal index approach, whereas in CRAF Phase 2, more complex modeling processes are used to analyze and compare the risk. In terms of assessment, CRAF Phase 1 will consider the entire regional coast sector of 1 km, where CRAF Phase 2 will focus on 3 or 4 potential hotspots to make the assessment. CRAF Phase 1 uses empirical simple model for the hazard pathway assessment applied on a uniform hazard pathway of 1 km. Simple bathtub and overwash extent model are used to assess, for instance, the inundation extent. In Phase 2, The pathway assessment is done using a 1D process-based multi-hazard model and used between 5 or 10 transects per kilometer. The inundation extent is calculated using least flood type inundation model. In terms of impact, CRAF phase 1 only consider exposure and provide exposure indicators. CRAF phase 2 include vulnerability indicators and calculate the impact in terms of direct impact, disruption, and long-term impacts. CRAF phase 1 output are hotspot identification, which are required to proceed to CRAF phase 2. CRAF phase 2 provides as an output the hotspot selection. CRAF phase 1 calculate a coastal index per sector of 1 kilometer and for a given probability. The coastal index is calculated using a hazard indicator and an exposure indicator. The exposure indicator is composed of different sub-indicators, a land use indicator, a population indicator, a transport indicator, a utility indicator, and an economic indicator. The coastal index is value between 1 and 5 and helps then to identify the hotspots along the coast. As you can see on these figures here, the red sectors are the potential hotspots. Here is the same on this coast, where the red and orange are potential hotspots. CRAF phase 2 can then be used to compare the identified hotspot at regional scale by scoring and ranking the potential impact using a suite of models and a multi-criteria analysis. On this example, hotspot A, B, and C will be compared. First, hazard process-based model, XBitch1D and a 2D flood model will be used to assess the potential hazard extent and intensity for given probability. This information will be inputted in the INDRA model with information on the receptors type and using information from the vulnerability library. The INDRA model then calculates the potential impact and use a multi-criteria analysis to rank the different hotspots. In our example, A will be scored with 0.35, B with 0.13, and C 0.28. Depending on the quality of the information, A will be selected as the hotspot, or A and C will be considered as potential hotspots.